Hey guys, my name is Arshi, and I'm a member of Team 5795. In this video, I'll be going into the science to explain the bottle rocket that you may have seen previously on our channel. So, just to refresh your memory, I'll walk you through the steps of how to make the rocket, but do know that there's another video on our channel that goes into much more detail in a demonstration of this bottle rocket. So, first things first, you make a paper cone and strengthen it with duct tape. Then attach this cone and tape it on to the bottom of a 1-liter bottle. Using a knife or other cardboard cutter, you can make 4 triangular fins to tape them to the bottom of your rocket, or this is the top of the bottle. Make sure to ask an adult for help if you do need it. Then, using a stretchy or malleable material like clay or Play-Doh, you can add a ballast or weight to the opening of the bottle. Then fill your bottle up with water, put a pump needle into a cork and put the cork into the bottle opening, and then use your pump to make your rocket blast off. So, to understand the rocket science behind this experiment, there are 2 important parts on the rocket, the cone and the fins. So a cone usually refers to any type of 3-dimensional shape that tapers down to one point from a circular base. This cone is known as one of the most aerodynamic shapes, and it minimizes the drag or air resistance, almost like it's cutting through air. So some cones that you might know of are ice cream cones, traffic cones, megaphones, but this cone shape can be seen in a lot of projectiles or things that move through air or another liquid. Like you see on the side here, a football has a cone-type shape on both edges so that it moves through the air, and a torpedo underwater also has this cone shape. The next important part of on the body of the rocket are the fins. So these fins help the rocket fly straight, giving it direction and stability. Where the cone almost seems like it's slicing or cutting through the air, the fins actually allow that air to travel down the shaft or the body of the rocket, making the space between the fins almost act as tunnels for that air to go through. Now, there might have been some words that I just told you about that are a little bit confusing. So I'm going to be breaking down the 4 main forces of aerodynamics and also an introduction to what exactly aerodynamics is. 2 of the forces that we see on the rocket or any type of projectile are weight and thrust. Weight is a downward force, kind of like gravity, which keeps us on the surface of the earth. Weight also includes the mass of the projectile, whether that be the plane or a rocket ship. Thrust is the propelling force, the push or the pull. And thrust is also aided in this situation, our bottle rocket, with the pump that we use to project the rocket. Now, you might have heard me say aerodynamics a number of times. So aerodynamics is just a branch of science. This branch focuses on studying the motion of air and the forces that apply to the things that move through air. Lift and drag are the last 2 forces that I'll be talking about in this video. Lift is the upward force. It is opposite of the weight, and it's the force that allows the object to fly. If you look at the diagram on the right-hand side of your screen, you'll see that lift is the arrow that points upward. This helps the projectile fly. Now, I do have to be honest with you. lift is not as significant in the case of the rocket because of the rocket's upward direction. Thrust, which was a force we talked about just a second ago, holds a lot more importance, and it's also aided, like we said before, with the pump. Now the last force is drag. I also mentioned drag when I talked about the cone. Drag is the resisting force of thrust. It's the friction that holds back the projectile or stop it. Drag is something that runners and swimmers both experience, which is why they tend to wear tight-fitting clothing to minimize anything that can hold them back. That was the end of the video, a super fast, super brief introduction to the science behind our bottle rocket. Thank you so much. Don't forget to like this video and subscribe to our channel if you want to see more videos like this and get to know a bunch more fun robotics stuff.